Okay, g'day everyone. So we're just going to do some strand 7. First things first, change our units to megapascals because that's the way I like it. And then we're going to create some nodes. So we go up to create node and then we put it at the origin and then 7 meters above that because it seems like a good cross section. Then we go into tools, copy by increment, and we're going to copy them 1 meter in the X direction and repeat that twice we repeat that. So what that's going to give us is 3 nodes, and obviously they'll be spaced 1 meter apart. Then I'm going to copy those in the Y direction, downwards, upwards apparently. So we want to do it in -4 meters because we're going to have 3.5 meters of water, so that gives us 3.5 a meter of clearance. Then I'm going to take these 2 nodes in the bottom right and I'm going to copy them by increment of 9 meters, which puts us halfway to the other side of the Cassian structure. Then what I'm going to do is create some beam elements. So create beams between those 2. So that's in create beam elements, and then we select them. And the shortcut I use here is Control-Shift-S, just so that I can select them easier, and that's the subdivide tool. And then I'm going to subdivide them 9 times, which gives us 9 1 meter increments. So there you go. And that makes your math nice and easy when you're putting on your loads. So the next thing I'm going to do probably is put in some beam elements for the whole structure. So we're just going to do it all the way around those nodes. And it's all beam element 1, beam property 1, you'll see in the top left there. So now we're just going to select that middle one. Note what I did there with that toolbar is at the top you can select nodes or beams and the mouse pointer, so you can choose to be able to select nodes or beams. One of the more annoying things about strand. Now we're going to go node, restraint, and we're going to just fix that node in the middle there, which just makes it fixed obviously. So it's going to emulate what our cables do with some degree of accuracy. Now we're going to go attributes node and we're going to put a force on those ones that are in the bed structure, and I'm going to make it something like water in the -Y direction. So 3500 is what I know it was, and you just get that by multiplying the density of water by the height of the water, by gravity, and then I multiply it by 3 because this cross section is meant to be 3 meters to the next one. So then we go into property beam, and we're just creating, so we chose structural steelwork, and now I'm choosing a cross section, so I went into BHP welded beams, and then I made it 1200 by 522, which is pretty much the biggest cross section you're going to get in strand 7. And it's always good to use one of these standard geometries because you know it's going to work. However, if you want to, you should probably look at something like One Steel catalog to make sure that you're using something that you can get in Australia, just to make sure that your design is legitimate. So these are all the cross sections that you can go for. Obviously try and go for Australian or well-known ones, so BHP welded beams is a good go. Coolio. So then I just pressed F5 and now we can see what our cross section looks like. So you can see now that our cross section is actually going into where the water should be, right? So we're going to need to edit this design a little bit such that the water is no longer being impeded by our cross section. However, first things first, I'm just going to subdivide everything into nice 1 meter increments because that's the way I like it. I'm going to put some forces on the side walls, so in the -X direction because it's on the side obviously and water's just pushing out, and I'm going to do it density of water multiplied by the depth of the water multiplied by 3, and there should be gravity multiplying that as well, but I forgot at the time. And now we do the same thing, it's like 1.5 meters depth, and that one's going to be 2.5 meters depth. And then the final one, so down there, that one's actually going to get half the amount of vertical water pressure as the other ones, and 3.5 meters of sideways depth force. Makes sense. So I'm just going to apply those forces, and it should be a kind of diagonal arrow coming onto that one, but this arrow is more or less negligible. It's not a huge deal if we don't put that in, but it is necessary to make sure the load case is correct, and I've done it in the wrong direction. Keep an eye on that. Okay, now that we've got our forces and our fixtures in place, we're going to need to fix our outside nodes. So what we're going to do is we're going to use the YZ symmetry button. So what that allows us to do is pretend that the rest of our cross section is mirrored about the YZ plane. So I've just fixed them using that tool, and now I have to save it in order to run it. And we're just going to solve it using the solver linear static. So it's just going to run, it won't take too long. And that warning, I think, is just because of the mirror, the YZ symmetry restraint that we used. So now you can see it's deflected because I set it to 10% deflection. And we're going to open up our results. We're going to get a contour, and I'll set it to stress and total fiber. And now we can see we have 115 megapascals of stress, and that's occurring right in those corners there. Right, so where it's pink. It's pretty simple. So now what are we going to do in order to improve that stress? So we can see that we're kind of compressing a lot, and the lower section is not really giving any assistance to the upper section, right? And we're getting a lot of bending. So what I'm going to do is I will create some new nodes, new beams, sorry. Oh, actually, the first thing I'll do is create a rigid link between those two nodes, just to show you what would happen if you rigidly link them together. So this is pretending that they were like perfectly linked together, those two nodes, which is a non-real solution. However, it does well to illustrate what's going on. So let's solve that again with a rigid link. It'll give us a warning that rigid links are a non-real solution. And then you solve that, and look, we're down to 80 megapascals. So we've improved it a lot just by connecting those two beams together. Righto, so we still got a lot of stress there in bending. So what are we going to do? We need to reduce the bending stress on that section. So what I might do is kind of try and spread the load a little bit out of that bending section, bearing in mind that pretty much all the force has to go up through that vertical section there. So I'm going to delete that rigid link because it's a non-real solution and I don't like it. And I'm going to create beam elements, property 2, so that we can use lighter beams for this part. And I'm just going to try and make a truss that's regular, but I think I'll stuff it up. A good way to do trusses like this is you put the vertical sections in first, and then you put in your diagonal sections, so that way it's always regular, but you can see that I've done it non-regular. So we go into property beam, and then you select beam 2 attributes, and then we go into our cross sections. So I've just chosen a smaller cross section, but 500 tall, something a little less beefy than the 1200 beams that I was using for the blue parts. So now we've got that loading up, and there you go. And I'll press F5, and there you go, you can see what it looks like. And we've kind of got a bit of a reasonable attachment between the top and bottom halves of our Cassian structure. So I'm going to try and straighten that up now. So you put in more diagonal bits, which I'm trying to get right. Yeah. and I am not getting it right. And so yeah, I just did it the way I said before, is you just put in the vertical sections and then put in your diagonal sections. Just make sure your vertical sections are consistently spaced. It's not actually hard, I just had a lot of trouble with it. Okay. Now we solve it again, and let's see what stresses we get out. So we're down at now 40 megapascals, 37 megapascals. Yeah, that's looking pretty alright. So now I've got something reasonable. So I'm just going to move it around a little by middle clicking, and then you can drag with the left click. So you middle click and then use the left click to navigate in the 3D space. Right, now I'm going to delete our restraints on those middle ones. I'm going to do selecting beams and nodes and Control A, and then I'm going to mirror them about those 2 points. So select one of those points, mirror in the YZ direction, and ta-da, we have a complete cross section. Next thing is I'm going to solve it, and it should be identical to having it with the YZ symmetry constraints. And ta-da, it's identical. But it is nicer to look at. I suggest you solve these using the half structure constraints. So what you should be thinking while you're looking at this is ways to reduce the peak stresses on your structure, depending on how you have it anchored and how regularly your ropes are coming down. It mightn't be this easy. So now that I've done that, I'm going to show you how to, so that's one I did up earlier, and I'm going to show you a quarter model. Here we are. So that's a quarter model I did up just before. Okay, so now I'm going to show you how to make a quarter model. So the first thing that I've done is I've copied some nodes around, but I've got some stray nodes, so I'm just going to tidy those up. So just, select node and delete them. And then, once I've deleted those nodes, I'm going to select all of the nodes and I'm going to copy them by increment, and I'm going to do that in the Z direction by 3 meters. So now I've copied all the nodes, and that's important because we need to create our longitudinal beam sections. So you can see all the nodes are copied in the Z direction by 3 meters there, and I'm just going to create some beam property 1 longitudinal sections. So all I'm doing here is just attaching those beams to their respective nodes. It's pretty simple. This takes a little while, so feel free to skip ahead if you don't like watching longitudinal beam sections be put in place. So I'm just putting them at 1 meter sections, but I decide I don't like it there. And now I'm just going to put them at hard points. As you can see, it's moderately challenging to actually select the correct nodes, right? So you kind of need to finagle it a bit and move around to see what's going on, because the nodes are pretty small. It's quite difficult to know where they are, but you get the hang of it. I'm going to do the same thing for the bottom half. Couldn't be bothered to copy them, but you could copy by increment for those beam elements. Okay. Now that we've copied all those, we're going to go such that we can select beams and nodes, Control A, tools, copy by increment, and we're going to copy the whole lot 3 meters in the Z direction. And we're going to do that 20 times, because 120 divided by 3 divided by 2 gives us a quarter model of 20 times. Now, we have a quarter model. So I've just gone middle click and then I've centered the whole model and we can see it. So there's your quarter model. Yours should be a little bit more structurally well thought out than mine. I've just put something together, but there you go. Now I'm just going to delete all those end bits. Just selecting nodes and whatnot, just cleaning up the model, because you don't want to have leftover nodes because it will ruin your solver. Okay, just making sure that there are no stray nodes, which I don't think there are. Looks good, cool. Now what we can do is mirror the whole lot again, I think. So we'll make a half model. So in order to make the half model, we need to select all the nodes, every single one, and all the beams. So we go node and beam selection, and I'm going to go Control A, Tools, Mirror in the YZ plane, that's the right one, and then I'm going to do that about that point. Now we've got a half model. How exciting. You'll note that the forces on the very central nodes are doubled. Now that's because we've mirrored them about 0 distance, right? So they're actually superimposed upon themselves and they have the force doubled. You've effectively copied the mirror, the node onto itself. So when you do this, you need to think about those forces. So now I'm going to show you a quarter model that I did up myself before, right? And I've put on all the correct constraints for the 3-dimensional quarter model, which you can think about. I showed you how to do symmetry constraints before, so it's not that hard. It's pretty much the same. And we just solve it, and now let's look at the stresses. Rightio, so you'll see that we have 140 megapascals of stress, which is not ideal, and that's occurring in these vertical sections here, right? So we're getting a lot of bending going on, which is not ideal. So why is that? Well, I think it's because we've got it anchored in the wrong way, or we've got too much force in places that we don't want to have it. So that is your task.